Okay, let's try this example one more time. We want to use the even and odd properties to find the missing trigonometric functions, okay? So we're given sine of theta is equal to 1 over 5 in quadrant 1. So if we're given a quadrant, that means we want to actually put it in that quadrant. So we first want to go ahead and draw our x and y axis here. And then our triangle is going to go in quadrant 1. And I say triangle because remember that first and foremost, sine, cosine, and tangent, they're ratios of sides of a right triangle. So if we go ahead and put that right triangle there, remembering that our theta is right here at the origin, okay? So there's theta right there. So remember that sine theta is opposite over hypotenuse, opposite over hypotenuse. So that means that 1 is our opposite side and 5 is our hypotenuse. So using our theta, our angle of perspective right here, here's our opposite side, and here's the hypotenuse. So we can go ahead and place those two sides. Now, in order to find the rest of our trigonometric functions, we do need our adjacent side. And so we're going to use our Pythagorean theorem to find our third missing side here. Okay, go ahead and plug in our values. Remember, 5 is our hypotenuse, so that's going to go in for C. Square things, subtract square root. And of course, you always want to leave your side in lowest radical form. So you don't want a decimal there. So this is going to be plus or minus 2 radical 6. And since we're in quadrant 1, x is positive in quadrant 1. So our side is 2 radical 6, a positive. Okay. Now, this brings us to our missing trig functions. Okay. What we need to remember is that our reciprocal functions are the flips of our original. So our cosecant theta is hypotenuse over opposite, the reciprocal of sine. Our secant theta is hypotenuse over adjacent, the reciprocal of cosine. And cotangent theta is adjacent over opposite, which is the reciprocal of tangent. Okay. Now, cosecant theta is actually quite simple because I already have sine and I can just flip it. So cosecant theta is 5 over 1, which just simplifies to 5. Secant theta is going to be hypotenuse over adjacent, so that's going to be 5 over 2 radical 6. Okay, 5 over 2 radical 6, but again, can't have that radical in the denominator, so I have to rationalize it. Multiply top and bottom by radical 6, and it simplifies to 5 radical 6 over 12. Okay, that's our secant theta. And then cotangent theta is adjacent over opposite. So adjacent here is 2 radical 6 over opposite side, which is 1. That just simplifies to 2 radical 6. Okay, now we want to find even and odd properties. So if we are using our even and odd properties from the last slide, we should remember that secant is even, okay, so it keeps the sign. Cosecant and cotangent are odd, so they're going to change signs. So if I want cosecant of negative theta, I'm going to get negative 5. Secant of negative theta keeps its sign, so 5 radical 6 over 12. And cotangent of negative theta changes sign, so negative 2 radical 6. And that gives us our even and odd, our missing trig functions with using even and odd properties there. Okay. If you need to rewind this, listen to it again. Let's talk about graphing the cosecant and secant and cotangent functions. Okay. Graphing the cosecant function, you have to make sure that it connects with the sine function. So if you'll notice here, we have our sine function here in the blue, going up and down, up and down. That's our sine function, okay? Basic y equals sine of x, okay? So a few properties to remember here, and you have this written down in your notes, but just to talk through them. When sine is positive, okay, cosecant is also positive. So notice here, sine is on the positive side, sine is on the positive side. Okay, that means cosecant right here is also positive. Okay, and remember, if you want to find the value of the cosecant function, you just do 1 over whatever the sine is. Okay, so if you do sine of negative 3 pi over 2 and you get this value here, this 1, you're going to do the reciprocal of 1, so 1 over 1 is just 1. Over here, if we were to take this value here, let's say that's 0.5, that's 1 over 2. Reciprocal, flip it, so that's going to be 2 over 1, which is 2, which is right up here. Notice it matches up, okay? So you're still using that reciprocal property to find the values of cosecant. So when sine is positive, cosecant is positive. Similarly, when sine is negative, cosecant is negative. Because you're only doing the reciprocal. You're not doing the opposite. You're just doing the reciprocal there. So the sign remains. Now, when you have sine is equal to 0, at that point you have 0 over 1, and flip it, you get 1 over 0. So this is where these asymptotes are coming in, these undefined asymptotes. Okay, notice that that's right where sine is equal to 0 every single time. So when your sine is equal to 0, your cosecant is undefined, which results in a vertical asymptote. And then, of course, when sine is equal to 1, cosecant is also equal to 1, like I mentioned right over here. Okay, so it's literally just a flip. But again, when sine is equal to 0, you have those vertical asymptotes because 0 over 1 flipped becomes 1 over 0, and you cannot divide by 0, which makes it undefined. Okay, so those are qualities and properties of a cosecant graph. Now, when we take a look at a secant graph, secant is the reciprocal of cosine. Okay, so notice our cosine graph down here. Okay, and again, notice our vertical asymptotes right where cosine is equal to 0. Every time cosine is equal to 0, we get a vertical asymptote because, again, right, when we have 1 over 0, we cannot find a value for that. That's undefined. And so our secant graph looks like very similar to the sine graph, okay, or very similar to the cosecant graph, in the sense that we have vertical asymptotes. And again, when cosine is positive, secant is positive. When cosine is negative, secant is negative. When cosine is 0, secant is undefined with the vertical asymptotes at those values. When cosine is equal to 1, secant is equal to 1. Okay, the closer the cosine graph is to 0, the further the secant graph is from 0. So the closer that, notice here, the closer that our cosine graph gets to 0, right, the farther the secant graph gets from 0. So if cosine is going down, cosecant is going up. I'm sorry, not cosecant, secant is going up. If cosine is going down, secant is going up. Okay, that's what essentially that last line there means. Let's take a look at cotangent. Okay, the function and graphing properties of cotangents. So the tangent graph is our blue here. That's our tangent graph. Okay. No, I apologize. The tangent graph is our red. Tangent graph is our red here. The colors are throwing me off here. Tangent graph is our red. And notice it's just kind of like a reflection on the other side. So instead of going up from left to right, you're now going down from left to right. But properties are similar. Okay, tangent is positive. That means cotangent is positive because, again, remember, we're not changing signs. We're only flipping the numbers. When tangent is negative, cotangent is negative. When tangent is 0, cotangent is also 0. Okay, notice we don't have our like a change in asymptotes. Tangent always had asymptotes, so cotangent always has asymptotes. Okay, so when tangent is 0, cotangent is 0, and when tangent is undefined, cotangent is undefined. Okay, and when tangent is equal to 0, then when tangent is equal to 1, then cotangent is equal to 1. So tangent and cotangent probably have the most similarities in the graph, and you can see that. It's just a reflection of each other, where if tangent is a big number, then it becomes a small cotangent number. If tangent is a small number, then it becomes a bigger cotangent number. So it's really just going in a reflected direction. Other than that, everything else kind of stays the same. And remember, if you want to find and graph a tangent and a cotangent, all you got to do is find its reciprocal. So if you're trying to graph cotangent, then you graph the tangent and then you find the reciprocal of those values. And those are your points. So it's all about the reciprocal, guys. All about the reciprocal. Okay. Okay, I hope that this makes some sense. If you guys need any more guidance on this, I would highly suggest that you go to Khan Academy and Google graphing reciprocal trig functions and see what videos pop up, or do the same thing, graphing reciprocal trig functions on YouTube and see what videos pop up so that you can actually get some examples or a different explanation for these graphs and get a better understanding, okay? So I've attached your classwork and your homework to the set of notes here, and I would like you guys to go through and complete them to the best of your abilities. All right, have a great day.